I've added some methyl alcohol. Methyl alcohol, as you well know, is flammable. And in all but the first dish, I also have a variety of salts. Most of them are chlorides, a few or some other stuff. And what we're going to do is ignite the methanol, and then the energy that is given off by the burning methanol will cause the atoms in these salts, the metals in the salts, to be reduced, and then the electrons excited. And it turns out that some of these excited electrons, then when they relax, they emit light in the visible region. So we'll be able to hopefully see something in the dark. If I can find where I am. The first one I'm going to do is pure methanol, so that you know what methanol's color is like. So you can see it's got a blue color. And most alcohol, look, there's a little bit of impurity in there too, because you're seeing bits of other stuff. But mainly it's that blue coloration that I want you to know. So on all of these, you will see this blue coloration due to the methanol. So this first one that I have is calcium. So again, you're going to see the blue coloration, which is due to the methanol. But you also should begin to see, it's almost like in the first one too, as the methanol burns down, it's going to start interacting, the heat will interact with the salts. And you should be able to see a little bit of reddish orange showing up now. See that reddish orange? That's characteristic of calcium. I don't know whether you all ever did flame tests back in high school or whatever, but that was one of your tests to determine which elements are present, and calcium turns to burn with this reddish orange flame. It doesn't really burn, it's the electrons are excited, meaning they go to a higher energy state, and then they relax. And in the process of relaxing, they emit light, and in some cases in the visible region. Now this next one is, I can't tell. All light I'll be able to tell you. So again, the blue is the methanol.
Green.
It's nice emerald green, yes. Let me get this box out of the way.
Ooh.
That's copper. And copper does, when it is heated up, the electrons are excited, it does emit this beautiful blue-green coloration. Alright, so we'll find out what the second one is.
Wait, what was the green one?
Oh, yes. This is
Bless you.
potassium.
Bless you.
Potassium, I can tell, is a little bit contaminated, but do you see the lavender flame mixed in with that? And that lavender flame is characteristic of potassium electron. And so as you're beginning to see that each atom, for each type of atom, produces a different colored flame. And that colored flame deals with the electron being excited and then relaxing. Chemists have learned that this has something to do with the structure of the atom, where the electrons are located, even though we can't say for certain. All right, next one. Now you're beginning to see it like an apple green or a yellow green. seen when you've gone out to see fireworks. If you have a fair last night, they had a whole bunch of them going off. And you can sit there and say, oh, how do they produce all those different colors? They use different salts that produce a characteristic colored flame. Or not really, the flame is colored, but it's the electrons that are emitting this light as they relax. And so the next time you go to the fair, you go, oh, lithium. Impress all your friends. Sure.
I don't think they'd be very impressed.
These are really neat things to see. I really love the lithium and the boric acid. Some are more intense, and some atoms don't really emit anything in the visible region. They will emit light when the electrons are excited. It just may not be visible to our eyes. So the question for you is to be thinking about is what does each of these unique colors have to do with the structure of an atom, the arrangement of the electrons. And this is what chemists